Okay. 3.6 is where we're going to start looking at how you combine your different functions together. Okay, so we're going to start looking at how do we actually add, subtract, multiply, divide, or towards the end of the section, how do we actually do what are called compositions, where we're putting one function inside the other. So to start with, we're going to look at just straight, good old-fashioned combining of functions. Okay, so when we combine functions, we can combine them in 4 different ways. We have addition, subtraction, multiplication, and division. Well, it's the same as straight, good old-fashioned addition and subtraction, multiply, divide when you're talking about numbers or variables. The only difference is here you're going to actually have combinations because you're going to be multiplying, dividing, adding, subtracting one expression onto another. Okay? So you have to pay very close attention to what your sign is so that you know exactly what you're doing. Because the first thing you have to be able to do is combine your functions however you're supposed to. And then in some instances, you'll be asked to evaluate. Now, these evaluations can be done with just straight numbers, or you could evaluate using actual expressions themselves. So again, it's going to depend on what it is you're being asked. Now, the biggest thing that you have to remember is when we are talking about division, you need to remember your most important rule for fractions, which states that you cannot divide by 0. Therefore, you always have to make sure when you are evaluating your division that whatever you're evaluating by is not going to ultimately give you 0 in the bottom. Okay, so you need to make sure you're following that rule. So let's go ahead and take a look at an example. So this first example here says that you need to use the appropriate operation. Okay, so here we have let f of x equal this following expression, and let g of x equal this expression. So first of all, you're supposed to find f minus g. And this part here, this tells you your evaluation. So in this case, we're telling you to evaluate by x. Okay, so let's go ahead and look at this first part. So we have to find f minus g. Well, to find f minus g simply says, first we're going to write the function of f, and I'm going to stick it in parentheses so that we can keep them separate. So the function of f was going to be x squared plus 3x minus 8. And then we have to look at the function of g. So we are subtracting, that's our operation. And then I'm going to open a new parenthesis here and put in the function of g. So this becomes 4x plus 5. Now once you've put your expressions where they belong, you then have to do the math. So the math here says that I have to take this negative sign and I need to transfer it through my parentheses into the back. And so here this is going to become x squared plus 3x minus 8. And then I get a minus 4x minus 5. Well, I need to combine my terms to get my final result. So here, this becomes x squared. 3x minus 4x is a negative x. Negative 8 minus 5 is a negative 13. Now, at this point is where you would look to see how you were being asked to evaluate. And in this case, we were being asked to evaluate by x, meaning this would be our answer, because that would be the only thing we have left. Okay? Now, the other part we had to this problem wanted us to find f plus 6. But in this case, we are being asked to evaluate by numbers. So this is what we are evaluating. And for the purposes of this part, it's going to be 6. So once we get all the way down to the bottom, you'll see what's going to happen with that evaluation step. Okay. So again, we have to start, and we are doing f plus g. So again, I need to start with f. So here I've got my parentheses, and it's going to be x squared plus 3x minus 8. My operation this time is plus, and then my g term was the 4x plus 5. Now remember, whatever this operation is has to flow through the back part of the parentheses. And in this case, because it's addition, nothing is going to change. So that's going to mean that our function here is going to be x squared plus 3x minus 8 plus 4x plus 5. And we're going to combine our terms here. It's going to give us x squared. 3x plus 4x gives you a 7x. And the negative 8 plus 5 is a negative 3. Now the last thing we had to do is we have to evaluate by 6. So now we have to look at f plus g evaluated with 6. So what does that mean? Well, it means anywhere I have an x, I have to input my evaluation. And here, my evaluation was a 6. So I input my 6's. 6 squared is going to give me 36. 6 times 7 is going to give me 42. And then minus 3. So we have to do 36 plus 42 minus 3, and it's going to give us a total answer of 75. Okay. So notice the difference in the look of the two examples here. The first part has evaluate by x, therefore an expression is our answer. But the second part we had to evaluate by an actual number. Therefore, a number will be the answer. Okay? Okay, so let's look at another example here. Let's look at this one. Now, here again, we have two equations. So we have f of x equals x squared minus 3. And then we have g of x equals 2x plus 1. Okay. So with that, again, we're asking you to do f times g and then evaluate it too. And then we're asking you to do f divided by g evaluated at -1/2. So I'm going to go ahead and work the simpler one first, because we all know multiplying is a little bit easier than dividing. So we're going to look first at doing f times g. So to do that, again, says I'm going to first do my f, which was x squared minus 3, and I have to multiply this by my g term, which is 2x plus 1. Now if you look, I now have two binomials. So two binomials multiplied together means that you have to use the FOIL method. FOIL says first, outer, inner, last. So here, this is going to be the same as when we were doing it before. So first, x squared times a 2x is going to give you 2x cubed. Outer is going to be x squared times 1. So this is plus x squared. Inner is going to be -3 times a 2x, which is a -6x. And last is -3 times 1, so a -3. Now if you look at this, there is nothing to combine as all of my terms are separate and different. So now the only thing I have to do is I have to finish out the evaluation piece. So here I have to do f times g evaluated at 2. So again, this means anywhere you have an x, you have to input 2. So this becomes 2 times 2 cubed plus 2 squared minus 6 times 2 minus 3. Okay, so we have input that 2 everywhere we needed to. And so now we have to simplify. So if we look at each of them, 2 cubed is 8 times 2 is 16. 2 squared is 4. Negative 6 times 2 is a negative 12 minus 3. So if we look at this, this is 16 plus 4, which is 20, minus 12 minus 3 gives you 5 as an overall result. Okay. Now, just as a side note, I wanted to show you that there is a different approach that you could use for a problem such as this. Some of you may find it to be easier, but some of it may find it to be a little bit confusing. So it's up to you if you choose to use it. So first and foremost, we are doing f times g, and we are evaluating at 2. So one thing that we could do with that is we could look at first doing f of 2, and then multiply that by g of 2, and see if we get the same result. So f of 2 says in my f function, anywhere that I had an x has to become a 2. So my f was x squared minus 3, so this becomes 2 squared minus 3, and that's my f. And I'm going to multiply this by the g function. And g was 2x plus 1, so this becomes 2 times 2 plus 1. So now let's simplify. So when we look at this first part, 2 squared is 4, minus 3 gives you 1. And then we're going to multiply that by the second part. 2 times 2 is 4, plus 1 is 5. So when I multiply those together, I get 5 as a result. So if you look at the two methods, and I separated them on purpose, this first method says that you're going to multiply your two functions together and then evaluate in the end. The second one says you're going to evaluate in the very beginning and then you're going to multiply it in the end. Like I said, it's up to you which approach you choose to use, but I do caution you, more mistakes are made for some reason when students evaluate first and then multiply. I don't know why. It just tends to happen. So please make sure whichever method you are using, you are paying very close attention to the work that you are doing so that you are not making any mistakes. Okay. Now the second half of this problem says that we need to do the division and we need to do it at -1/2. So because we're dividing, again, the biggest thing that you need to remember is going to be this piece right here that states that whenever dividing, you need to make sure that you always check your domain of the function first before you even get started with your division. Okay? So we need to check the domain of my function. So here I'm looking for the domain of my fraction. So I'm going to look at the domain for f divided by g. And in this case, what does that actually mean? Well, my fraction rule states that I cannot have a 0 in the denominator. Therefore, what that means is that this means that your g cannot be 0. Okay? Well, in this case, what do we know? We know g of x is 2x plus 1. So therefore, 2x plus 1 can't be 0. Therefore, 2x can't be -1, or x cannot be -1/2. Now, slow your horses before you get all excited, because we do actually have to set up your division. So first and foremost, we know we need to do f divided by g. My function of f was x squared minus 3. My function of g is going to be the 2x plus 1. Now, that is simplified as far as we can. There's nothing else for us to do. So the evaluation piece, okay, we need to do f of g and evaluate at negative 1/2. However, we got a slight problem. Our domain says we can't use negative 1/2, which means our evaluation here does not exist. Okay, D and E does not exist. The reason for that is you cannot evaluate at this value because it fails your domain. Oops. Okay. So when we're looking at this, the function does not exist. Okay? Because the evaluation term falls outside the scope of your actual domain. Okay? Okay. So let's look at another one. Alright, so we have this one, which you'll see in Hawks kind of shows up fairly often. So first and foremost, there's a little kind of note that you need to keep in mind. When you have any variable raised to a fractional power, the way that fractional power is read is that your numerator term is the power of the exponent, and your denominator term is the power of your index for your radical. Okay? So, first and foremost, you have to know or be able to remember how that actually works in terms of setting things up. So here we have that f of x is x to the 3/2. So one thing that you need to keep in mind is that when you have f of x being x to the 3/2 power, that is kind of the same thing as recognizing that you actually have the square root of x cubed. Okay? Why? Because remember, the numerator tells you the power of the exponent and the denominator tells you the index of your radical. So my index here is 2, that means square root. My power is 3, which means the square root of x cubed. So now we're being asked to find f plus g. So f plus g is going to be the following. Your f of x, so you can write it as x to the 3/2, and then plus g, plus the absolute value of x. Now the other way that I would accept that would be for you to say the square root of x cubed and then plus the absolute value of x. Okay? So either one of those is going to say the same thing, but then we have to evaluate by 3. So to evaluate by 3 says now we're going to do f plus g, and we're going to evaluate this at 3. Which says anywhere you have an x, you have to input your 3, which is why knowing how this changes is kind of a big deal. Okay? So first of all, we've got 3 raised to the 3/2, and then plus the absolute value of 3. Well, to make that easier, we know 3 to the 3/2 is the same thing as saying the square root of 3 cubed plus the absolute value of x. So what do we know? Well, we know that 3 cubed is 27. So this here is going to be the square root of 27 plus the absolute value of 3. Well, the absolute value of 3 is 3. So this is going to be the square root of 27 plus 3. Okay? Now, once you get to this part, this is where you need to find out if you have round to the nearest as part of your directions. If you don't, then that's how you leave your answer. But notice in this one, we have round to the nearest hundredth, which means we are expecting you to go ahead and calculate out to give the decimal. So we have 3 raised to the 3 halves, and then we are adding 3 to that value. So we got to take the square root of 27 and plus 3, and as long as I did my math right, you should come up with something along the lines of 8.196. And now remember, hundredths means 2 places, so the 6 forces the 9 to raise, so this becomes 8.20. And that would be your result. Okay? So again, pay attention to what it is that you are combining back and forth. And remember, if you have a fractional power, then you need to follow this rule that says the power of your numerator is going to be the exponent, and the power of your denominator is going to be the index of your radical. Okay? Alright, now we need to switch gears just a little, because not only can we evaluate these things, we can also find the domain of these things. Okay? So finding the domain, this is where things become fun, because it's not just about evaluating, but it's about knowing what's going on with every part. So, first and foremost, if you are given 2 functions, then in order to find the domain, means that you have to first find the domain of each function. I highly recommend that you graph each function on their own number line so that you can simply look for the overlap of those graphs. Okay? So, here we're going to look at combining functions and seeing what's going on with them. So first and foremost, we have find the domain for the function f plus g of x. Okay? So to kind of save some time, I've already graphed out the number lines, but I'm going to talk you through them so that you definitely understand what's going on. So first and foremost, we know that f of x is 2x plus 3. Well, 2x plus 3 is a linear line. So when we're talking about the domain of a linear line, we know that that domain has absolutely 0 problems. So if this is the negative infinity and this is the positive infinity, my domain here is going across the whole number line. Okay? Now, g of x is a little bit different. G of x here is a radical. And here the rule for radicals says that you cannot have a negative under your radical sign as long as your index is even. Therefore, when we're talking about the square root of x, we know that x has to be greater than or equal to 0. So again, if this was the negative side and this is the positive side, then we know that for this particular number line, we can start at 0, and we're going to shade everything in that positive direction. Okay? Now last is looking at the domain of the combined. So first of all, we have to know what the combined function is. So f plus g is going to be negative 2x plus 3 plus the square root of x. Now there's nothing that we can do to combine that, so that's kind of how it stays. But furthermore, the combined is going to be the overlap of my two functions. Okay? So the combined is going to be the overlap of f and g. So we are going to look at f and g here, and we are going to look at where we're the same. And we are the same at all points greater than 0. So this ends up being the parts that's shaded. So in order to actually do this, you have to use interval notation, which says that your domain is going to be from 0 up to positive infinity. And the 0 is included, so we use the bracket. Okay? So that's kind of what we're doing when we're talking about finding the domains of your combining functions. Now, with that being said, we do have some general information that we have to follow. First and foremost, when we are talking about f plus g, f minus g, or f times g, all three of those will have the exact same domain. Okay? So f plus, f minus, and f times, when you combine it, they will have the exact same overlapping domain. The domain that's going to differ is going to be this one here, which is f divided by g, okay, or g divided by f, depending. And the reason for that is because the fraction has a very specific idea, which essentially says that you cannot 0 in your denominator, okay? And so because of that, it means that this one has a restriction. Whether it's f divided by g or g divided by f, you are restricted by the denominator cannot be 0. Okay? Now, the only other one that has a restriction is your rational or radical, which says that your radical must always be greater than or equal to 0. And so therefore, those are going to be the 4 different types of domains that you are going to find as you work your way through your practice. Okay? So let's look at another example. Again, to save some time, I've pre-drawn it out so that we could just simply talk through it. And here, we're asked to do 2 different things. The first thing you're asked to do is f plus g, and then you're asked to do f divided by g, and in both instances you're asked to find the domain of each. So the first thing we need to look for is when we're finding the formulas, you need to do just that. So when we do f plus g, it's as simple as taking f plus g and adding them together. So this is going to be 2x squared plus 2 over x minus 5. Now in this case, there really isn't a whole lot that's going to be done in order to simplify it, so most of the time you could just leave that as is. Okay? Now, for the other one, we have to do f divided by g, so I'm going to kind of skip down to the bottom of the page. So f divided by g is going to look a little different. So here, my f was 2x squared. But then my g is 2 over x minus 5. So here, one thing that we can do with this is that we can make it look slightly nicer, because we know fraction over fraction means keep the top, change the sign, and flip the reciprocal of the bottom. So this is going to be the same as 2x squared times x minus 5 all over 2. Okay? So in some instances with Hawk specifically, you might be inputting a problem like this one, where you get a message that says you are not in its simplified form, which means you need to do a little bit more math. Now, you could go as far as to say multiply this through, which means you technically could say that it was 2x cubed minus 10x squared. But most of the times you should be able to input it just in this first way without issue. Okay, so just pay attention. But that at least is finding the formulas for both f plus and f minus. Now we have to be able to find the domains. Okay, so let's come back over here. And the first thing we need to do again is we need to find the domains of the individuals. So first and foremost, we have f of x. Well, f of x, if we look, is just 2x squared. So 2x squared is essentially all real numbers. So we have shaded in the entire number line here to represent all real numbers. So this is the negative, and this was the positive. Okay. Now, when we're talking about f of g, or g of x, sorry, we are now talking about the fraction. Okay, so we're talking about this fraction here, where we have 2 over x minus 5. Well, again, remember, what's important is that your denominator can't be 0. So x minus 5 can't be 0. But that's the only place where we're going to have an issue. So when we solve for x, you get that x cannot be 5. And so here, notice, if this was my negative and this is my positive, I've left a hole here at 5. However, everywhere else works without any problem. So we have shaded in the whole rest of it. So the only place that we don't have shading is right there at 5. We got a hole that, say, your pen could drop through. Now, if we look up at here, we've got f plus g. So here, we have to use the overlap between f and g. So if you look between these two, my overlap is going to be sitting at everywhere works except at 5. Okay? So therefore, excuse me, again, we know that my f plus g is going to work everywhere except at 5. So here again, we still have this hole because we still have to take the domain of g into account when we do it. Okay? Well, the other thing that we have to be able to do is write the interval here. So the interval here is going to say that we can go from negative infinity up to 5, union from 5 to positive infinity. And that is going to be the domain of f plus g. Well, the last thing that we have to look at is we have the domain of your division, f divided by g. Okay, so again, if we look, we're doing f over g, which means g is my denominator. Okay, so we are still going to be using the overlap between f and g, but g is the denominator. So in this case, we still have the problem at 5. So we're still shading everywhere other than that. Okay? And so here, it just so happens that this domain ends up being the same. Negative infinity to 5, union 5 to positive infinity. Now that's just this particular problem. As we do some more examples, you will see that not all of them always end up being the same domain. It's really going to depend on what was your numerator, what was your denominator, and what is your problem actually doing. Okay? So let's look at another example. Alright, so here again we're doing the same thing. We need to first find f plus g, and then f divided by g, and then we need to find the domain of f divided by g. So first let's look at finding f plus g. So f plus g is going to be the following. F is x cubed plus 4, and then g of x is going to be the square root, so plus the square root of x minus 1, and that's f plus g. F divided by g is going to be my f on top, which was x cubed plus 4, but in this case now we're going to divide it by g, so divided by the square root of x minus 1. Okay, so we have found f plus g, and we found f divided by g, so now we can find our domains. Okay. So first and foremost, we have f. So the domain of f of x, again, x cubed plus 4 is going to have no issues. So it is all real numbers, so we're going to shade the whole thing here in blue. Again, remember this is the negative and this is the positive. We then need to look at g. So g of x was a radical. And remember the rule for radical says that the stuff under the radical must be greater than or equal to 0. So here we've got x minus 1 is greater than or equal to 0. So x is greater than or equal to 1. So notice here I'm including 1, and I'm shading everything to the positive. So when we do f plus g, again, we have to look at the overlap. So we're looking at the overlap between f and g. So we have my overlap between the blue and pink lines, means I'm overlapping here at 1, and I don't have any problems. Okay. So again, I have to write this as an interval. So I'm going to include 1 and travel up to positive infinity. Now the last one I have to look at is, again, I have to look at my division. So I'm looking at f divided by g. And in this case, we got to remember that g is the denominator. So now when we look, the radical is on the bottom, which means it can no longer equal 0. So we have to include a new rule. And the new rule says the stuff under the radical must be greater than 0. Okay, since it's in a denominator, I now have to follow the fraction rule as well. So here this says that x has to be greater than 1. So notice I now have a hole here. So in looking at my hole, if you remember, we would use that with a parentheses. But essentially the 1 cannot be included, and we are going to travel up through the positive infinity here. So again, I have to write this as an interval, and notice my interval is going to change. Now I use a parenthesis around the 1 because I can't use it. So the 1 is no longer included in the domain. Okay. So this is an example where all of my domains don't end up being the same because I have to use the rules that are used with it. Alright, let's look at another example. So here in this example, notice I've changed it up. In this case, I'm going to use f minus g. And now I'm going to use g divided by f. Okay? So let's look at what that would look like. Well, first and foremost, I have to do f minus g. So my f term here is going to be x squared minus 1. So this is x squared minus 1. And then I have to subtract away my g term, which is the cubed root of x. Okay. So that is going to be my f minus g. Now the other thing that I have to do is I have to look at g divided by f. So this means g is on top, so this is the cubed root of x, but then f is on the bottom, x squared minus 1. Okay? And so that is going to be g divided by f. So now we have to look at all of the pieces that we need. So first and foremost, we've got our f of x. Now we've got x squared minus 1, so we know there that's going to use all real numbers. So again, my f is going to include the entire number line. Okay. So there's the negative, and here's the positive. Now, when we take a look at our g of x, okay, which is this one, g of x was this one here, which is cubed root of x, and that also is going to have no problems. So just like the first one, it is going to use the whole number line. It is all real numbers. So from negative to positive, we don't ever have an issue. Well, that makes it really easy, because f minus g is going to be the overlap between the two. So I'm going to look at f, I'm going to look at g, and I'm going to look at where they are identical. So here, my blue and pink lines are identical everywhere, which means f minus g also uses all real numbers. It also incorporates the whole number line. So when we write its interval, we are going to write from negative to positive infinity. Okay? Now my problem is going to come from when I do my denominator. So in this case, I'm doing g divided by f, so I have to notice here that f now is the denominator, which means my domain is going to change. My domain now is going to be that x squared minus 1 can't be 0. Therefore, x squared can't be 1, so x can't be positive or negative 1. So if you look, my domain here is going to be the combination of f and g taking the new rules into account, which say that x cannot be 1 or negative 1. So notice I have two holes in my graph now, but everywhere else I don't have a problem. So when I write this interval, what you have to remember is you need one more interval place beyond how many x terms you've got. So we have 2 x values where we have a problem, so I'm going to have 3 intervals. So my interval is going to go from the negative infinity to negative 1, and then I have to union that from negative 1 to 1, and I'm going to union that from 1 to positive infinity. So remember, your interval should match what your number line looks like. Okay? So that's kind of everything that you need to know about combining functions and finding their domains. Okay? Now, the other type of combining functions we have called compositions. Okay? So, composition of functions. Composition of functions says that you are going to take one function and input it into the other function and then evaluate. So, I like to think of them kind of like a job. Okay, I don't know how many of you actually have a job, but if you really think about your paycheck, okay, in terms of your job, let's say you go and your boss tells you that he's willing to pay you $10 an hour for 40 hours of work a week. And you say, sure, great, sounds good. Okay? So in your mind, you're thinking, ooh, 10 bucks an hour times 40 hours is $400 a week. That's pretty good, which it is. But then you get your paycheck and you notice it's not $400. It's less than that. The reason for that is because, oh, guess what? Taxes get involved. Okay. So taxes are kind of like your function. So the first function you've got would be essentially your income. So whatever you made, that total pay that you make then has to be evaluated through taxes. So taxes is that percent of your pay. Okay. So if you look at this example here, we're saying that if you work 40 hours a week at $10 for 1 week, your total pay would be $400. Now let's say taxes were 8% of your income. So what happens is that paycheck of yours then has to run through your taxes function. So in other words, taxes would be, say, 8% of that $400, which is $32. And that would be taken out of your paycheck and, say, paid to the government. Whippy, yippee, skippy. That means your paycheck that you would get when you opened it up would say $368 because 32 of it went to taxes. This is composition of functions. It is taking one function and inputting it into another function to spit out an evaluation. So we have some notation here that we have to pay attention to. And your notation is this. If you see the word fog, it's not actually the word fog, it's saying f of g. It means f of g of x. Okay? In other words, g of x is the input and f of x is the overall. Okay? But you could also reverse it and you could do g of f, which would mean that f of x was your input and you were inputting it into g. Now, if you notice, this means we're going to have an awful lot of x's that we're working with. So one trick that I used when I was first learning compositions is I would take the x's out of my outermost function. Okay, so what do I mean by that? I want you to find the composition f of g of these two functions given. So f was written first, means it's the outermost function. It means what I'm actually asking you to do is do f of g of x. And so my f is 2x squared minus 3x. Okay, so my composition is going to be that I'm going to take my f and I'm going to create myself a space. So this is 2 times something squared minus 3 something. And the something that's going to go in there is going to be your g. Okay? So if we actually look at this is going to be 2. My g was x plus 7, so 2 times x plus 7 squared minus 3 times x plus 7. Now you have to actually simplify that down. So we have to do x plus 7 squared, multiply it by 2. So this is 2 times, well, this is a binomial, so we got a FOIL. So x plus 7 squared is going to be x squared plus 14x plus 49 minus, and we're going to distribute the whole thing through, so minus a 3x minus 21. You got to distribute the 2 through, so this becomes 2x squared plus 28x plus 98 minus 3x minus 21. So this is going to give you 2x squared plus 25x plus 77. Now, the other thing that you have to keep in mind is that, again, this piece right here is going to tell you what you're going to evaluate by. Well, for us, this was just an X. So that means I'm done. I don't have to do anything further. And I have my answer. So this part right here is the answer that I was looking for. Was the 2x squared plus the 25x. Okay. Alright, let's do another one. So let's look at this one here. And so again, we're going to be evaluating, and this time we're going to do g of x, but if you notice, we actually have an evaluate term. So the first thing you need to do is find your composition, and then you can evaluate. So we need to do g of f. So again, I'm going to take my g, I'm going to remove the x's and give myself an input spot. So this is going to be something squared minus 2 times something minus 6. And remember, what's supposed to go in here is my f term. So this is going to be my 3x plus 1 squared minus 2 times my 3x plus 1 minus 6. So I got to square the first term. So 3x and 3x is a 9x squared. And then this is going to be plus 6x plus 1. So distribute your 2 minus 6x minus 2 minus 6. So when we do that, okay, we've got my 9x squared. 6x minus 6x means it goes away. And then we have 1 minus 2 minus 6. So that is a negative 7. So minus 7. And so that is going to be f of g, or g of f, sorry. So now we need to evaluate that by negative 2. So we have g of f evaluated at negative 2. Means this is 9 times a negative 2 squared minus 7. So negative 2 squared is 4 times 9 is 36. Minus 7 gives you 29 as a result. And then again, this was the answer we were looking for. Now, just like before, I want to point out a second way that you could approach this when you have a number to evaluate by. Okay. So again, we are looking at g of f, but we are evaluating by a negative 2. So if we know what that looks like g of f of negative 2. Okay. That's what we're actually doing. So here, if you think about it, we are going to do g of, and then if we look at our f was 3 times a negative 2 plus 1. Well, we can evaluate this middle part. So this means we're going to do g of 3 times negative 2 is negative 6 plus 1 is a negative 5. And so here, now we have to evaluate or plug the negative 5 into g. So this becomes negative 5 squared minus 2 times negative 5 minus 6. Well, what does that give us? Negative 5 squared is 25. Negative 2 times negative 5 is a plus 10 minus 6. Well, 10 minus 6 is 4 plus 25 gives you 29. And is that not the same answer? So then, whichever method you choose to use to evaluate is perfectly fine. However, I do caution you to be careful. A lot of mistakes get made when we try to use the second method, but I like to show it just so that you have another approach. I would recommend doing it this top way, or quote the blue way, because you're probably prone to make less mistakes evaluating only once, whereas down here, if you notice, you had to evaluate twice. Again, it is up to you, but that's just two different ways that you could approach compositions. All right, let's look at this one. So here for this one, I want you to go both forwards and backwards. So I want you to find f of g, and then I want you to find g of f. So f of g. So we have x squared minus 3 and 4x minus 3. F was written first, it's the outer one, so I'm going to go input space squared minus 3. What goes in here is my g. So my g was 4x minus 3 squared minus 3. We need to FOIL this binomial term. So 4x times 4x is a 16x squared. 4 times negative 3 is negative 12. So this is a negative 24x. Negative 3 times negative 3 is a positive 9, and then minus 3. This is going to give me a result of 16x squared minus 24x plus 6. And here, this is what we were looking for. Okay. Now we need to look at doing g of f. So in this case, g is the outermost term. So I have 4 something minus 3. And in this case, what goes in here is my f function. So this is going to be 4 times x squared minus 3, and then minus 3. Well, all I have to do here is distribute, so this becomes a 4x squared minus 12 minus 3, which is going to be 4x squared minus 15. And so here is this result. If you look at the two results, you should see that you have two separate answers, which is actually to be expected. So when you evaluate forwards and backwards, if you don't get the same result, it doesn't mean you did it wrong, it usually means you did it right, as you are evaluating your functions in two different ways. Okay? Okay. Now, just like before, we can evaluate our domains. So the biggest thing that we have to remember is that when you are looking at the domains of your compositions, the first thing you need to do is find the domain of each function, and then write out what the composition is. You need to then find the composition of your function, and then to find the overall domain means, in terms of most of your expressions, if the answer for the composition is fractional, then your domain will exclude the values that make the denominator 0, okay, using your fraction rule. If the answer for your composition is radical, then remember that under your radical must be greater than or equal to 0. Now the other piece that has to be considered is the fact that you have to consider the domain of your input term, which is why writing out the composition definition becomes important, because you have to know which one of your terms is the input term, okay, that's going in, because that domain kind of has to be considered as part of your domain structure. Okay. So let's look at this crazy example and see if we can figure this out. So it says find the formula and the domain for f of g, and then do it again for g of x. And so we have f of x and g of x. Notice both are fractions. So the first thing that we have to do is we have to know the domain for each function. So I need to know the domain for my f. Well, my domain for my f says that my denominator can't be 0, so x can't be 0, which means I am looking at the interval negative infinity to 0, union 0 to positive infinity. Now the other thing that I have to know is I have to know the domain of g, which is going to say that 2x plus 1 can't be 0. In other words, x can't be negative 1/2. So its domain is negative infinity to negative 1/2, union negative 1/2 to positive infinity. Okay. So once you know the domain of each, we now need to look at what the composition is by definition. So the first thing that we are going to do is we are going to do f of g. Okay. So by definition, we are doing f of g of x. It means this part right here is your input function. So we can go ahead and evaluate. So f is the outermost term, so this is 6 divided by, and then notice x is on the bottom. So it's 6 divided by something. And the something that goes in there is g. And g was 1 over 2x plus 1. Now, when looking at this, we don't like this. So we have to actually do the math to simplify the problem. So once you do it, the next thing you need to do is you need to simplify. So simplify here says keep the top. So this is going to keep the top. And I'm going to multiply it by the reciprocal of the bottom, which is going to be 2x plus 1 over 1. So in turn, this is going to become 12x plus 6. Well, if you actually look at the domain now of this, we have a linear line. So my domain here of my f of g is going to be negative infinity to positive infinity, because it's a linear line, which means it doesn't have any errors or any issues at all. Okay. Now, the other one's going to be a little bit different. So the second thing that we're going to look at here, make sure you can see it, is we are going to look at g of f. So again, by definition, this means we are doing g of f of x, which means in here is my input, the f of x part. Okay. So we have to look at what is actually going on here before we do anything else. So g is on the outside, So this is 1 over, and then this is 2 times my stuff plus 1. Well, my stuff here was 6 over x. Okay. So I actually have to do a little work to simplify this down. So I'm going to multiply in. So this is going to become 1 over 12 over x plus 1. I have to combine my fractions, which says that this is 1 over. What's missing is my x, so this becomes 12 plus x over x. Okay. And then again, keep the top, multiply by the reciprocal of the bottom. Means that this is going to become x over 12 plus x. Okay. Now, if we look at this one, we have an issue here because we have a fraction. So when I'm looking at my domain for g of f, I have to take into account that 12 plus x can't be 0. So in this case, what does that mean? Well, it means that x can't be negative 12. Okay. And so that's the domain that we are looking at there. Okay, is that 12 can't be included. So my interval here is going to go from negative infinity to negative 12, union 12 to positive infinity. Okay. So that's one example of using or finding the domain of compositions. Okay. Now let's look at another, and this one is a little bit more engaging or challenging than the last, because notice my rationals here are slightly more involved. And again, I want to find the domain of f of g. Okay. So the first thing I need to do is I need to know my domain of f. My domain of f says that x minus 1 can't be 0, so x can't be 1. Now the other thing I need to look at is my domain of g, which in this case says that 3x minus 2 can't be 0, so 3x can't be 2, so x can't be 2/3. Once you found your two domains, now we need to look at what is the composition we're doing. Okay, so here we are going to do f of g, which again, by definition, says we're doing f of g of x. And therefore, that means that my g of x here, this one right here, is my input term. Okay. So, first and foremost, we need to look at making that composition. Okay. So f is on the outside, so this is going to be 5 over my stuff minus 1. And my stuff here is going to be 4 over 3x minus 2. Now again, the next thing we need to do is we need to simplify. So again, if you look between these two, the part that's missing is this 3x minus 2. So here I'm going to have my 5 is over, and this is going to be 4 minus that 3x minus 2, and the whole thing is over the 3x minus 2. And so now I need to continue to simplify. So this is 5 over, distribute the negative, so this is negative 3x and a positive 2. So 4 plus 2 is 6 minus my 3x all over that 3x minus 2. And then from here we need to apply our rule, which says keep the top, flip the reciprocal of the bottom. So this is going to be 5 times the reciprocal of the bottom, so 3x minus 2 over 6 minus my 3x. And so we're actually going to rewrite that as its fraction. So this becomes 5 times 3x minus 2, and the whole thing is over 6 minus 3x. Okay? So this is what I was looking for. Now, there's a couple things that we have to keep in mind when looking at this particular domain. First is this part right here has your domain of G. Okay. So you can't forget that. So your domain of G is right there, because what we actually had in this was a fraction within a fraction part. So we need to keep in mind that this piece actually had a domain. Well, the other thing that we have to keep in mind is that this whole thing itself also has a domain. So when we're looking at the domain for my f of g, well, this tells me that 6 minus 3x can't be 0, which tells me that x can't be 2. Okay, subtract 6, divide by negative 3. That x can't be 2. So in order to find my overall domain, I have to use the domain of G and the domain for f of G, which says that I have to use that x can't be 2/3 and x can't be 2. So therefore my domain here is going to be negative infinity to 2/3 union 2/3 to 2 union 2 to positive infinity. And that is the domain for this one. Okay? Alright, the very last one that I wanted to look at real quickly is, well, what happens if we're given a radical? Okay, so again, we're going to find f of g and g of x. So we're going to go f of g and g of f. And we're going to go ahead and look at the domains of both. So first thing we need to do is we need to look at the domain of f. Well, f is a linear line, so its domain is going to be negative infinity to positive infinity. It's all real numbers. And then we need to look at the domain of g. Well, here, this is a radical. So here, x must be greater than or equal to 0, which gives you an inverse, or an interval, starting at 0 and going to positive infinity. Okay? Now that we know that, we need to look at what was f of g and what was g of f. So, f of g again, remember, is f of g of x. So here, f is 2 input plus 1. So this is going to be 2 square root of x plus 1. So if we look at the domain here, we have to look at the domain of this value. So my domain for f of g essentially is going to be my radical piece. So again, x is greater than or equal to 0. So if we look at that, that means it has an interval 0 to positive infinity. And then, sorry, this is a bracket. Now the other thing we need to look at real quick is, say, g of f. So remember, this is g of f of x. So here, this is g of x is the square root. So this is going to become the square root of f, which is 2x plus 1. So to find the domain for g of f, it means the stuff under the radical must be greater than or equal to 0. So 2x plus 1 is greater than or equal to 0. So x is greater than or equal to negative 1/2, which tells you that it has an interval that's going to start at negative 1/2 and go up to positive infinity. And that is everything that you need to know about section 3.6. So, as always, please make sure that if you have any questions or concerns or issues, that you put those into that discussion board so that I can utilize those questions at our next virtual classroom. And as always, have fun and enjoy your math, and I'll see you next time.